So, okay, here comes our next family of modifications. So normally our original function, which is here, this is y is equal to cos of x. So Ikra, can you explain to us what has been the modification going from our original function y equals cos of x, which I'm going over in a black pen. Okay, what's been the difference between this one and the purple function written above? What have we done to it?
Added 90.
Now, where have we added this 90? Have we added it inside or outside, or where's this modification?
Inside.
It's inside the function. So when we put the plus 90 inside, every time we try to work out an angle, we are working out 90 degrees further to the right. We're dragging. So for example, let's say we put in here 0. When you put 0 into your function, you're actually working out not 0, but you're working out instead what you're working out? 90. So at this point here, you're actually working out this value. So this value goes to here. Okay, let me grab a purple. No, that's a blue, purple. So this point is going over here. That's what we're doing. Now, if you put, for example, in here 90 into your function, obviously you have to add 90. So what are you actually working out?
180.
So the 180 value will be dragged to the 90 point. So everything, if you have a plus 90, everything is then being translated towards the left. So we've got left translation, left. So everything is moving this way by 90. We're translating the whole graph. We're grabbing every single point. So we've just done 2 points there. And we're going to grab this point and move that back by 90. We're going to grab this point and move that back by 90. Everything moves back by 90. So let's start doing that now, putting the new points in. One there, one there, one there, and one there. So I'm going to get rid of the original one so I don't confuse myself with which point I'm going to be drawing. Let me put the black point back in. Oops. So let's start drawing now on the purple one. Come on, Salia. So we're going to have, okay, that's going to be the downward stroke. And then we're going to draw the upward stroke. And then we're going to draw this one here. Oops. Okay, right. I'm going to try to get rid of those curvy lines because they're kind of making it look a little bit confusing and a little bit. Okay, so I'm just going to get those bits off now. Trying to make the graph look a little bit more nice and cleaner. Okay, right. So we got that bit now. So Ikra, does the graph look finished to you? I mean, looks like we got a little bit missing. What's happened to our graph?
It's cut off short. So
it's cut off short because that's the last point that we have. But really, in real life, the graph actually goes down to here, doesn't it? Mm-hmm. So we need to grab that point and drag it back here because of the cyclic nature of the cos function that it goes on and on forever. So that point comes to here. So we're kind of cheating a bit because we know about the function. So we can then swing it back around again and bring it back down and give us more of a complete drawing rather than a little bit missing. I'll leave that out a bit on there. Are we happy with that?
Yeah.
So when we're doing the modification is a plus 90 on the inside of this particular function, it means that we're going to move everything to the left, translate everything to the left by 90. Now, similarly, if you have the same function, Ikram, you put a minus 90 in there. So if plus 90 means left, what does minus 90 mean?
To the right.
To the right. So move every point. Okay, when I say move, I mean really translate every point. Every point to the right by 90. So let's grab a point. Let's grab points. Let's grab points. Let's grab points. So 90 is 4 squares. That's 90 degrees. So I'm going to go 4 squares forward and drop it down there and put like a circle around it. The 90 goes to where, Ikra?
180.
Okay, and then the 180 at the bottom is minus 1. Where does that go to?
270.
270. And the 270 point position goes to where?
360.
Okay, so you're moving it 90 degrees along the graph. Okay, look, let's start drawing those up and see what kind of function we get. And I think I'm going to actually need to use a little bit of a, what color we're supposed to be doing? We're supposed to be doing a blue. Okay, let's get a blue now. Let me have a look at my, okay, what am I getting? I'm getting something like this. Remember, folks, try to make it nice and curvy as possible. And don't make it out of straight lines. So now, in this graph, similarly, we got the same problem where we got this region here, we got no graph drawn. So what do we have to do for that part of the graph?
Fill it in.
Remember, the original graph will kind of be going down like this. So we got to bring that point back this way to here, because we know of its cyclic nature. Fantastic, that's lovely, that's done. So we've done the cos x plus 90 and the cos x minus 90 as an example of what that does. Right now, I want everybody to have a go at the sine one. I think I've already, okay. So I'm just going to pause the video for a bit and everybody have a go at that one for me, please, now. Okay, so here's the answer that you should get now for the sine. So remember, if I, oops, let's get the keyboard down. Let's go back to green. If you put a plus 90 as our modification to the function on the inside of the function, the plus 90 means that we have to translate the whole function, grab every point and move it left by 90. So what I've done is I've grabbed, okay, we're grabbing every point. So this point here, yeah, this one here goes to there. This point goes to here. Okay, then we have this point goes to there. And then we have this point goes to here. So everything moves across, we draw it, and then this part was extrapolated. This part here was added on from what would have been over here. Bring it across. Similarly, for the on the right-hand side of the function, we have y equals sine of x minus 90. Minus 90 on the inside means that we're going to actually modify it by moving everything right by 90. Okay, so we're grabbing each point. Let me grab a blue. So we're grabbing this point, that's moving by 90 degrees, 4 squares. That point moving 90 by 4 squares. This one by 4 squares. This one by 4 squares. Then we get the blue function. And that's the end of this small video. Hopefully that helps. I'm going to take those points off if you like. That makes it a little bit easier to understand the question. Okay, and take these points off here as well. You can go back and watch that part of the video. Okay, I think we have covered everything that I wanted to cover from those different types of modifications. Okay, right, that's the end of those little small series.